Yeah, I'm looking and reaching, I'm hoping I achieve it. Now I'm chasing these feelings, cause I know they're always leaving. Now I'm running.
So hi guys, today we are gonna talk about problem, regression problem in ML, and what do we mean by regression, and how can we use that specific problem statement in machine learning. We're gonna explore all of these things, and why do we choose regression, and these kind of things we are gonna talk about on this. And okay. So yeah, regression is a type of problem in which we are given a set of inputs, and based on those inputs, or as I can say features, we have to predict a price. I'll not say a price, but I'll say a specific number. Okay, between it can be between anything, like it can be between from minus infinity to infinity. It can be anything. Okay, and yeah, so we're gonna talk about this, and like these kinds of problem we face in our ML machine learning, like how should we do that, how could we do that. Okay, so yeah, if we are gonna find like a problem statement, like what's the market price of this house. Okay, we are given some sorts of inputs like what is the garden area, how many bedrooms are there, and these kinds of input we have, and based on these inputs we are going to find a price for these. Okay, I'm not talking about the specific problem. We are going to discover that later on in our upcoming videos. Okay, and first of all, uh, one thing I'm gonna make clear, that if you have any doubt regarding anything you see in this video, comment it down, and we'll try to solve your comments as soon as possible. Okay, so yeah, let's go. Yeah, these kinds of question, like what's the market price of this house, and loan prediction, these kinds of things we are looking for. Okay, and basically regression comes in under supervised learning. Okay, there are three types of learning in machine learning. That's called supervised learning. Okay, and unsupervised learning and reinforcement learning. We are not gonna go into detail of these three topics I've told you about. Okay, I'm just gonna brush you up a little bit about what is supervised learning. So yeah, we're gonna talk about. Okay, so yeah, regression comes under supervised learning. There are two types of learning you are getting to see on your screen. That is, one is supervised learning and one is unsupervised learning. And there is one more type of learning, that is reinforcement learning. We're going to see all these types of things in our upcoming videos. I'm going to talk about it, and I'm going to tell you about it, how to approach these kinds of things, and how you can learn these kinds of things from our channel. If I have to differ between supervised learning and unsupervised learning in a line, I'll say that supervised learning means a labeled data, and unsupervised learning means unlabeled data. Okay, in supervised learning we have data that is pre-categorized, and in unsupervised learning it's vice versa. Like the data is not categorized at all, and we have to you know mm, find our valuable output through the use of algorithms like clustering, association, and dimensionality reduction. In clustering, there are so many algorithms like k-means clustering, and c-means clustering, and hierarchical clustering. We're gonna, I'm just gonna tell you about it. Okay, we're not gonna explore it in the in deep, but because our main problem of the day is regression, so we're going to talk about it. And moreover, I'm going to show you how to write a code, a simple code based on a simple data that depends on hours and scores, like how many hours you're going to study, so what's the score gonna look like. Okay, it's a simple statement with two features, that one is independent and one is dependent feature. Okay, And yeah, so it's not a classification problem, it's a regression problem. Many of confuse these two kinds of thing. Classification is very different and regression is very different. Classification means you have to classify between an apple and an orange. Okay, if you are given two things, like if I've given you two things, like if I've given you an apple and if I've given you an orange, you have to classify between these two, and you'll classify because you have learned what is an orange and what is an apple. Okay, so we feed these data, like these label data, like we tell our model, machine learning model, that this is apple, this is orange. These kinds of things we teach our machine learning model. That's how they learn and that's how they improve. After a series of experimentation and runs, that's how they improve. And on the other side, regression is totally different. You don't have to classify between an apple and orange. Rather than that, you have to predict the price of you know 1 kilogram apple and 1 kilogram oranges. These kind of things you have to do. Okay, like we talked about the problems, like what's the market price of this house, loan prediction, how much loan am I gonna get. Okay, these kinds of things basically. If I have to explain it to you in a layman language or a simple language, I'll just say that based on features and inputs we feed into our model, the price, the output is gonna come into between a number that is gonna be 0 to 1, and that is gonna differ based on what input we are feeding to our model. That's the simplest I can go. Okay, let's not waste our time, and you know so let's learn to code, how we can do it. Okay then. So yeah, before moving further, we're gonna look it up, like what is regression. And okay, we're gonna look it up, like what is regression, what's regression analysis. So yeah, over here it says, in statistical modeling, regression analysis is a state of statistical process for estimating the relationships between a dependent variable and one or more independent variables, often called as predictors, right? So yeah, it says also the most common form of regression analysis is linear regression. We're gonna see about that because there are so many types of regression problems. We're gonna talk about it in the upcoming videos. So yeah, let's move it on. So yeah, let's go and write our code. And before that, I'm gonna tell you one thing, that try to self-explore by yourself. Okay, what, like, if you, अगर तुम्हें कोई चीज नहीं समझ आ रही है ना, ठीक है, just try to Google it and तुम्हें वो चीज समझ आ जाएगी. एंड अगर फिर भी नहीं आती है तो यार हम बैठे हैं ना, यूट्यूब चैनल है यहाँ पे तुम्हें गाइड करने की, तो कोई टेंशन नहीं. ठीक है, so let's move forward. I'm gonna import some basic libraries. Okay, so these are the basic three libraries that gonna help you a lot in your data science and machine learning career opportunities. These are your best friends for a beginner, and not for a beginner, but these libraries are gonna help you a lot in future as well. These are very basic libraries, and you can do data manipulation, and you know you can play with data with these types of libraries, visualization and these kinds of things. Okay, remember that thing I told you about. If you have any doubt in this video, in a single line of code, if you have any doubt, you can comment it down, and we're gonna try to solve your problem as soon as possible. So yeah, from sklearn dot linear model, I'm gonna import my linear regression algorithm. Okay, sklearn dot metrics. Sorry, a typo. We're gonna import our accuracy score, right? And from sklearn as well. Dot model selection. We're gonna import our train test split, right? So yeah, let's run this. See, perfect run. Okay, so now I'm gonna read my data and see what does it look like. Okay, this is our pd.read CSV, and we're gonna see what our data look like. Score.csv. I'm not sure the file name is this. Yeah, I will write the scores.csv. So yeah, this is what our data looks like. The number of hours versus the number of scores. Okay, and we are gonna see something more about our data. Like we have non-null value. Okay, this is a very basic data set. Okay, so we're going to learn what is regression through this. And if you want a fully fledged a project, a bigger project, and you want to see that deployment as well in a web app also, you can comment it down, and we're going to try to make a video on that also. Okay, see, so this is hours column and this is scores column. We have 25 non-null value. This is float, this is string. That is very good. And we just need numbers to fit into our model. Okay, so yeah, let's go through some visualization as well, so we can see what our data is. Okay, let's go. I'm gonna just do a df dot plot based on that. So kind we're gonna let's go with scatter plot. Okay, yeah, so see, this is the our scatter plot. Okay, this is hours and this is scores. You have seen this data. Like let's grab a point. Okay, this is 7.8 hours and 86 score. So where is 7.8 could be? Where does 7.8 could be? I think it's supposed to be somewhere around this, right? This point. You can see this, right? So yeah, this is the point. Okay, so now we're gonna divide our data. We are gonna just do a simple reshaping and rescaling of our data, so we can feed that into our model, and based on that we're gonna make some predictions. It's gonna be interesting, guys, trust me about this. And after that, so I've fitted all my data into an array. Okay, and now I'm gonna make X test. Before that, I should make extreme, right? After that, y train and y test, and I'm gonna use train test split. It's used for splitting our data. Okay, yeah. So we are gonna use X. But we are gonna reshape our data for once, and so it can be. And I'm gonna tell you the reason why we are reshaping our data. Um, just let me write this, and I'm gonna show you like why you know we are, reshaping our data. So yes, let's go. And one more thing, if you ever, अगर तुम्हें लगता है ना कि जैसे तुम्हारा कोई कोड गलत जा रहा है, तो in Jupyter, I'm working in Jupyter Notebook, so you can just press Shift plus Tab. It opens up the documentation. Okay, you can look into it. Like I've used test size, I've used random state. Okay, so these kinds of things. For starter purpose, you can use that, and I'm gonna tell you why we were reshaping our data. Okay, so yes, let's go. We haven't run the cell below this. So yeah, let's see what's the shape of our data. See, it means 25 slash, 25 comma blank, 25 comma blank. And after that, we are gonna see what our data looks like as well. Okay, so yeah, let's see what our data looks like. See, we can't feed this into our model. Okay, we just can't. It's a list, like it's an array of a list. Okay, like we can't feed this into our model. We have to reshape it. That's why we are working on this. We have to just reshape it. And I'm gonna, because how can we see this data, like how can we tell our model that 2.5 correlates to 21 and 5.51 correlates to 47. Okay, I'm gonna run this. Moving on, and I'm gonna show you you know what our data looks like. So yeah, this is what our data looks like. This is X train. Okay, now it's properly reshaped, okay, into an array, and you can correlate that data with this. Yeah, I'm gonna cut this. This doesn't look nice, right? Let's see the shape of X train and Y train. Mm, yeah, so I'm gonna run it. Y train is not defined. Typo. Okay, yeah, see, that's what we want. 20 comma 1, that means 20 rows and 1 column. Okay, signifying it to a proper data. So yeah, after that, we're gonna load our linear regression model, and based on that, we are gonna make prediction. Are you excited? I'm damn excited about this. You know, every time I make a model, it just gives me chills. It's a art of you know data science and ML. I just love this. We have fitted our data. Okay, let's see. You know, we have got linear regression. That means that model is loaded, and we're now uh, gonna meet some prediction. Okay, lr dot predict. We are using lr because we have stored our regression model in lr. We are and we are gonna make our predictions on X test because that's a test subject, right? We have made predictions. Let's see those predictions. These are predictions. These are our prediction, and this is what this looks like. But how does we know how accurate our model is? Okay, we can see that our prediction looks like this, but how I'm gonna make sure that our prediction, you know, is correct. That's where accuracy comes. That's where the score comes. We're gonna see X and Y. Mm, we're gonna store our X train and Y train. And we're gonna get an accuracy. We got that accuracy, and we're gonna see what our accuracy looks like. So, yeah, 0.95. Guys, this means 95%. Okay, our accuracy is 95%. And now we're gonna do some visualizations. Okay, don't be afraid of this. If you don't understand anything about this, just message in the chat box. Okay, I'm gonna tell you all about it as much as I can. If you all remember, this is what our equation looks like. Okay, I'm gonna add a comment here. Y equal to mx plus c. Okay, This is our M is our slope, C is our intercept. This is what our equation looks like. Okay, what's the error? Line regression object has no attribute cover. My bad. Wait for it. There's a feature C. This is what we have to do, and we did it wrong. Doesn't matter. See, we got line, and if we print this line, we're gonna see what. See, we're gonna see the values of y. What the predicted value should look like. We're gonna see all these values. Wait for a minute. I'm gonna see score. Okay. I'm gonna see our score. Okay. So let's go. I'm gonna visualize this line, and we're gonna move with that. So yeah, let's go. I'm gonna plot. We'll do a plot our x, our line. I'm gonna plot. I'm gonna plot dot scatter. Okay. So let's plot our x and y's, what we stored, okay, and what was our original data at that point, okay. And I'm gonna add one more thing. Uh, let's see our visualized data. Let's see how much accurate our data was. We know that हमें पता है कि 95% एक्यूरेसी है, ठीक है, बट विजुअलाइजेशन के थ्रू ना और क्लियरली हमें पता चलेगा कि हमारी गलती कहाँ कहाँ थी. 95% एक्यूरेसी हमारी क्यों आई, नॉट करेक्टली क्यों आई, बट स्टिल हम विजुअलाइजेशन के थ्रू देख सकते हैं कि कहाँ हमारी गलती ज्यादा थी, मार्जिन ऑफ एरर हमें कहाँ हमारा ज्यादा था और कहाँ हमारा मार्जिन ऑफ एरर नहीं था, राइट. सो या वी गोना use X test, and we're gonna use our predictions. Yes, and I'm gonna add a legend. This you can see the documentation if you like. I'm just gonna close it. In this, I'm gonna add, first of all the line. Then we are plotting x and y, and that is our observed data, right? That's what we got from the CSV. Now we are gonna add our predicted data, right? I'm gonna add a marker here so it will be more clear to you. You can see that. What should we add? What should we add? Okay, so let's add a. Oh, okay. And I'm gonna do plot dot show. You're gonna see. Okay, error. P. Where's the error coming from? Oh my God, sorry. Mess up blunder. Prediction. Okay, another typo. Prediction. Here it is. And see, this is our data. We're gonna look more closer into this. So yeah, see, this is the line. This is the blue dots are observed data, and this peaky little yellow thing is our predicted data. So yeah, this is what we predicted, and what was, see, there is some difference between this yellow and this blue dot. That is what is the error from, coming from. This is, ये बहुत पास है, फिर भी ये वाला, ये बहुत दूर है, ये इसमें और इसमें थोड़ा डिस्टेंस है, ये थोड़ा फिर भी पास है. तो इनका एवरेज जो होता है ना हमारा एक्यूरेसी में दिख जाता है हमें. So we'll see about this. So let's assume that the student is gonna study for 9.25 hours. So what will be our predictor score? Let's use our model to predict the score. अब कोई स्टूडेंट इसको यूज करना चाहता है, मान लो इस हमारे मॉडल को, जानने के लिए मुझे उसको कितना पढ़ना पड़ेगा कि उसको एक परफेक्ट प्रिडिक्ट मतलब स्कोर अच्छा उसका मिल सके, ठीक है। सो ओके, वी गोना डू दिस एंड lr.predict, we're gonna name this predicted. Let's go with predicted. It doesn't matter what you name this. I'm gonna pass 9.25 and look closely here. Okay, I'm gonna pass 9.25. Oh, I've got an error. See, I wanted to show this error to you. Okay, see, it says expected 2D array. Got 1D array instead. Array 9.25. I'm gonna scroll my screen backwards. That's what was happening here, and we reshaped our data. राइट, मैंने रीशेप के बारे में बताया था। हम पास इसको 2D एरे कर रहे हैं, ओके, बट हम उसको स्केलर वैल्यू नहीं दे सकते। सो वी गोना टर्न जो वैल्यू अपने मॉडल को तुम लोग फिट करवाओगे, ठीक है, प्रिडिक्ट में भी और टेस्टिंग में भी, वही वैल्यू, शेप ऑफ दैट वैल्यू शुड बी सेम, unless otherwise it will not be, useful, or your model will get confused and an error like this will be there. So yes, see, the error got resolved. And what's our accuracy? 93.6917%. So if a student's gonna study for 9.25 hours, the accuracy will be approx 94%, or I'm gonna say the score will be around 94% because that's our dependent variable. Scores is our dependent variable. I'm gonna see upwards to find the maximum value here. What's the maximum value? See, this is the maximum value, 8.9. If a student is, the data is saying if a student is studying 8.9 hours, he's getting a 95% accurate score. Okay, but in hours is this, if a student is studying 9.25 hours, he's getting an accuracy of 94%, approximately 94%. It's happening because there's a little bit error in our model, but getting an accuracy of 95% in your beginning project, it's a very tremendous accuracy. It's a very tremendous achievement. So be proud of yourself that you have reached at this end of your video, and we're gonna meet to a next video, and we're gonna learn about more into machine learning. So till then, take care of yourself and subscribe, like, and share our video.
Again, see you again.